Hey, what's up everyone? Welcome to this Unreal tutorial. My name is William. Let's get into it. The learning goals for this tutorial are understanding blueprint variables. We will be looking at what variables are and how they store data in Unreal Engine's blueprint system. By the end of this tutorial, you'll be able to differentiate between variable types like booleans, integers, vectors, and understand their applications in the engine. Next, you will be gaining familiarity with the event graph, and you will understand how to use the event graph to execute blueprint logic in response to player input or events. Next, you will learn basic debugging with print string nodes that display text on the console for debugging purposes. You will also be able to manipulate actor location with vectors, and by the end of this tutorial, we will be creating a simple teleportation logic system. The learning outcomes for this tutorial are creating and using blueprint variables, and you will be able to define, set, and get variables and blueprints to control gameplay logic. Next, you will also be able to debug logic using print string nodes, manipulate object positions with vectors, and implement a basic teleportation system in a blueprint. Lastly, you'll also be able to apply proper blueprint workflow principles, utilizing best practices for organizing and structuring blueprint code for reusability and clarity. In this first segment of this tutorial, we will be looking at the basics of blueprint logic and variables, and we will be using it to set up a basic light switch system. So firstly, after you've downloaded and installed the engine, which is a prerequisite for this tutorial, we will be using Unreal 5.3 by the way. We will open up the engine and click on the Games category in the project window. And while we could select the third-person template, I'm going to stick with the blank template because I want to show you how easy it is to import other content into the engine once you've already created a project. And in that way, you will realize that it's very easy to do this and you don't have to work backwards and forwards or delete a project and start all over again just because you forgot to add a particular feature pack. It's also worth noting that I like to save my projects in a GitHub folder and a subfolder called My Project. I'm going to simply call this project Blueprint Vars. Vars is typically short for variables in programmer speak. I'm also in a blueprint project or creating a blueprint project as opposed to a C++ project, and we may as well bring in the starter content, which I'll be using too. After all of these settings are selected, we can click on Create. After a couple of seconds or minutes, Unreal will open our new Unreal project, and we have an untitled level, which you can tell by looking at the tab at the top here, and it happens to be a landscape level. If I just zoom in using W and cranking up the mouse wheel to increase the speed of movement, you can see is a large kind of desert-like terrain area, which is a little bit too complex for the purposes that we're looking at here. So what I'll do is I'll come up to the top here next to the Unreal logo and click on File, and I'll say New Menu or Control N. And from this new level pop-up window, I'll select Basic and click on Create. And now we're in a much more basic level where it's going to be easier to position the objects that we need and have a look at what we need to test out. So the first thing I want to do is import the feature pack that I mentioned earlier. And in fact, we're not going to bring in the third-person template. We're actually going to bring in the first-person template. So to do this, it's really easy. We just click on this Add button in the content browser down here. Next, we go up to Add Feature or Content Pack. And next, we select the feature pack that we want to import. So in this case, it's going to be the first person one, which is already selected. And I'm just going to click on Add to Project. You'll notice that behind the pop-up window, we've imported some items. And so once that's done, I can just close this window. I'm just going to gloss over what some of these items are that appear when we import the first-person feature pack. So firstly, and most important to us, is we have the BP first-person character class blueprint, which we need to put the first-person character in our scene. Next, we have the BP first-person game mode, which we need to tell Unreal that this is the game mode we want to use. So in other words, we want to use this first-person character game mode, as opposed to the default one in the scene, which I'll demonstrate in a second. Then we have the character class, which allows us to take control of this first-person character. The first-person projectile, which is a sphere representing a projectile or bullet that the gun will use. Then we have the pickup logic for the rifle or gun. And lastly, we have the BP or blueprint that determines the weapon component and how that behaves in the scene. It's also worth noting that aside from this, we have an input folder, which is where the input mapping and actions are located for this first-person game mode, which includes things like walking around and shooting the gun, as well as a maps folder that we will be using a little bit later on to just use this first-person map, which gives us some default objects in the scene to play around with. We also have the first-person character arms and animations, the first-person weapon, as well as some level prototyping folders. So first things first, we need to make sure that our game is using the correct game mode, because if we don't, it'll just be using the default game mode, which allows us to fly around in the scene, but doesn't give us control of the first-person character that we just imported. So for example, if I click on this play button up here to play the level in the active level editor, and I look around with the mouse and move around with the WASD keys, notice that I can sort of fly around in space as if I'm sort of a very robotic bird, but it's not what we would expect in terms of the first-person character controller, where the character would be grounded on the floor, running around as seen in many first-person games. So to get out of this preview, I will press escape to stop that game preview running. And what we'll do is set up the game mode. So there's a couple of ways of doing this, but a quick thing that we can do here is we can come up to this button that says list of all blueprints available, click on that drop down, and then right at the bottom we have a world override and it says game mode is not overridden. And to just make sure that we're using the right game mode for this example, we'll come down to select game mode base class, and then here we see BP first person game mode. So I'll select that. Now if I click on play again, and I move around with WASD, notice that I can't fly up into the sky. I'm grounded on the ground because I'm indeed this first-person character. However, we are not holding the gun because there's no gun pickup, which enables the gun component that I discussed a little bit earlier on, which is fine because we don't need that right now, and we can cover that in some later tutorial. But what's useful is if I press spacebar as I'm walking, you can see the character's arms flailing around or animating in accordance with how that logic is set up. So we know that we are controlling the first-person game character now. I'll press escape again to exit the game preview. The next thing that we want to do is populate our scene with some items so that we can kind of get more of a sense of depth perception and just make the level a little bit more interesting to look at. So to do this, we imported the starter content in the beginning. So if I click on the starter content folder in the content browser and next look for example, props, I have a bunch of props that I can add to the scene. So for example, I'll just add in this chair by clicking and dragging it with the left mouse button and positioning it in the scene. If I click on starter content up here at the top again to go back one folder, we could, for example, also click on this shapes folder, double click on that, and just add some simple shapes, like for example, a bunch of cubes by clicking and dragging them into the scene. And you get the idea. Please feel free to add your own objects. You can pause the video here and have fun creating a unique and interesting level. To give you more of a sense of how to do that, you'll notice that if I left click on any of these objects, and by the way, I'm rotating the camera by holding the right mouse button to look around, you'll see that we have transform arrows, blue indicating Z or up and down, green representing Y, and red representing X. So if I just click on any of those arrows and drag, I can move these objects around in 3D space. And if I select this cube by left clicking on it, for example, at the top here, we can also toggle between select objects, which is Q, translate or move objects, which is W, rotate objects, which is E, and scale objects, which is R. This is essentially known as the QWERTY shortcut, so it's the QWER at the top of the keyboard where the letters are. So for example, if I just press R or click on the scale icon, and what I can do is I can hold right mouse button and use the WASD keys to navigate in my scene. However, right now the camera is moving very quickly because my camera speed up here is very fast. So if I click on that, we can dial it down a little bit, or as we're holding right mouse button, we can use the mouse wheel and scroll down with the mouse wheel to slow it down. And you can see that value slowing down. If I go up, I can speed it up, and so this allows me to dynamically slow down the camera or speed it up as I'm moving around with WASD and right mouse button held down. So finding the right angle, I want to find the center cube in the gizmo for the scale tool over here, which is the series of cubes. And again, if I just left click and drag, I can scale this cube up. And the same logic would apply to, for example, rotating. If I just quickly go to the rotate tool, I can rotate this cube and maybe scale it a bit. And you can play around with that sort of logic to get the sort of look for your level that you'd like. Okay, so once you've had some fun with that and positioned some objects and transformed them in the scene, it's a good idea to save our level because we've obviously put a lot of work into this. So to do that, I'll go up to File and Save Current Level, or Save Current Level As. And we should actually create a folder for our levels. So if I right click anywhere in the gray area, I can click on New Folder, and the convention for this is often mapped. So maps like so. You could also call this levels if you'd like. The trick is to stay consistent with that. Once I've done that, I'm just going to make sure that I'm inside that maps folder, and instead of new map, I want to just call this level 1, for example. We now see that our level is called level 1. Once we've made sure that our level is saved, we can come back to the content folder over here in the content browser. The content folder is the main directory inside Unreal. We should create a blueprint folder next to store our blueprint in, which we'll be creating because, again, that's the whole point of this tutorial series. So I'll right click again in the gray area and click on New Folder up here at the top. And I'll name this folder simply BPs, which is short for blueprints. Next, if I go inside that blueprints folder, we do have the option of right clicking and creating a blueprint class over here, which we'll explore in later videos. But for now, I'm going to show you a slightly different approach. So instead, we'll create an item, add it to the scene, and then convert said item to a blueprint. So to do that, we can click on the Add menu up here, which is the cube with the plus sign. Click on the drop down, go down to Light, and select a point light. Once we've added this point light to the scene, we can easily convert it to a blueprint by coming up here to the Details panel and clicking on this button over here that says converts this actor into a reusable blueprint class. And if I click on that, I'm just going to stick the default option, which says that this is going to be a new subclass. And it's going to name it point light blueprint, which is fine, but the naming convention that I like to use is just _BP for blueprint, or we could even have it as a prefix as opposed to suffix. So we could come over here and say BP _point light, like so, and select that. Again, the trick is to just stay consistent with that. Next, our blueprint opens up in the blueprint window, or editor window. So what I can do is I can click and drag this tab, much like an internet browser, and just dock it up next to this one so that it's much easier to navigate between different tabs. Going back to the point light editor or blueprint, I just want to add one object here, which is going to be a collision object. So a collision object in game logic allows us to trigger things based on the user or player proximity to it. So for example, if the player enters a collision object, then we can spawn enemies, or in this case, switch light on and off. So to do that, I can click on add, which is much the same as the add menu that we saw in the level, except now it's in a blueprint. And I'm just going to search for collision because it's a bit faster. And you can see that we have, by default, some simple collision types, a box collision, a capsule collision, and a sphere collision. And in this case, I'm just going to simply stick with the box collision because it's nice and simple and easy to use for the purposes that we're going to use here. So again, we could rename this to something like _cold, which would indicate that it's a collider and just remind us that it's a collider, but it also has an icon that over time you'll get used to saying that it's a collision object. With that object selected, we want to scroll down in the details panel on the right, all the way down, until we see the events that we can add to this object. And I'm going to click on the plus sign next to add component begin overlap, which means that when the player overlaps with this object, something will happen. So I'll click on that plus sign. You'll see that we move from the viewport, which is this tab up here where we were previously, to the event graph, which is where all the blueprint magic happens. So to navigate in this pane, I can just right click and hold to pan around. And you can see we have this on component begin overlap, which I just explained. If I want to add more events, the details panel is a context sensitive window. So I need to select my box collider again. It reveals the events. And we also want to add an on-component end overlap so that when the player exits the collision, something else will happen. In this case, the light will switch off. So I'll click on this plus sign. Now we have a begin overlap for when the player enters this object and the light will switch on, and an end overlap when the player exits this object, the light will switch off. This is all just to give you a basic sense of how blueprints work before we move on to variables themselves. So to do this, what we can do is we can drag this point light component by left clicking and dragging into the event graph. And you see we get a node that says point light component. This represents the point light object in the scene or in this blueprint. And then what we can do is hover over this blue output, pull out a plug for this object or node and let go, and then search for set visibility. It's important that you use the set visibility for rendering as opposed to anything else, otherwise this won't work correctly. So let's click on set visibility. So right now what's happening is that we have our point light component and the visibility is set to false using a Boolean variable which holds a value of either true or false. We know it's false because the checkbox is not checked. If it was checked, it would be true. So another way of seeing this is that the light visibility is off. To get this to work in sequence with our on-component begin overlap event, we need to pull out this execution pin by clicking and dragging and hook it up to the corresponding arrow icon. You'll see a little tick icon indicating that this is compatible. Now we basically have an on-component overlap node saying that when the player enters this box collision, which it says up here, we will set the visibility to either on or off. To create another set visibility node that we can use to, again, either turn the light on and off, we could follow the same process as before, but we could also just select the set visibility node and press Ctrl D for duplicate. And now we have two set visibility nodes. Instead of creating two point light components, which will lead to spaghetti code later down the line, we can just hook up the same point light component to this corresponding blue input over here that says target self. To make sure that our on-component end overlap is also driving some sort of functionality, we simply hook up this execution pin to this one. And now both logics apply, so when the player enters this collision, something will happen with the light, and when they exit it, something will happen with the light. Currently, both visibilities are set to false, meaning that the light will be off no matter what. So probably we want to set the visibility of the light to true or on when the player enters this object, and have it set back to false when the player exits this object. Just for this example, feel free to play around with that logic yourself. So one final thing that we have to do here before this will work is we're going to go back to the point light component itself, and we need to scroll down until we see the rendering section, and we need to make sure that by default the light is not visible in the game, because otherwise it will just be visible already, refuting having it turn on when the player enters this collision object. So we'll uncheck this, again, Boolean variable, true or false, making it false or off by default. Next, it's important to make sure that you click on this compile button to ensure that the blueprint is compiled, and also click on the save button, which removes the asterisk next to the blueprint name, telling us that everything is saved, compiled, and ready to run. Although a lot of this can happen automatically inside Unreal these days, it's a good idea to just follow that practice to avoid complications when debugging. So next up, I'm going to go back to the level, and immediately, if I look around, we can see the blue sphere indicating the light radius. And then we can see that the collision object itself is actually quite small. So what we can do is adjust both the light and the collision size. So if I go back into the blueprint, back to the viewport tab, we can scale down the light radius itself. So here we have, for example, attenuation radius, and we can crank that down until it's a lot smaller. And then we can left click to select our collision object. And again, we can just press R to go to the scale tool, or click up here and just scale that up so that it's substantially bigger than the light itself. And we can select both of those holding shift if we need to see them both at the same time. If I go back to my level, and before I do that, I'm just going to compile and save my blueprints again. If I go back to my level, we can see that the collision is substantially bigger than the light itself. So the next thing I'm going to do is click on play to see what happens, and try and find the area that the light is. So it's a good idea to just first increase the intensity of the light, and you can do this before you actually convert it into a blueprint, but I skipped that step. So here in the details panel, just so that we can see it in the actual game view, I've turned, if I go to the light component, I've turned visible back on just so that we can test this out in the viewport, and I can increase the intensity of the light quite substantially, and I can also play around with the size of the light and the other settings here if I need to. I can click on this light color, for example, and I can change it to maybe something between a pink and an orange color. And again, you can play around with that. And I can play around with, for example, that attenuation radius, just so that we can clearly see this light. I can also click on this drop-down arrow again, and I can say apply instance changes to blueprint, which will apply these changes into our blueprint without us having to do that back and forth. So again, I'm going to turn off visibility for this light in the blueprint, make sure everything's compiled and saved once again, go back to my level and run the game. And there we go. When I enter the collision, the light switches on. It's of course also worth testing to see that when you enter the collision, the light switches on, and when you exit that collision, the light switches off. So moving on to the crux of the matter, what are data types or variables? So often we need to store values in programming logic and then be able to access and dynamically change these values. So what does that mean? Let's say that we want something to be switched off, and when it's switched off, something else happens. How do we do that unless it's built into a specific node? We can use variables to do that. So we can use, for example, a Boolean variable that says, when this is off, do something. We can also use values, so like floating point values or numbers, to increase or change things like the light intensity. So to create variables, we can come into the variable section, and click on add. And you'll see by default, we create a variable called new_var, and it's a Boolean by default. So what we can do is we can call this first variable is on to keep track of whether the light is on or off. So true in this case would mean that it's on, and false would mean that it's off. And this is just a way of keeping track of whether it's on or off. If I look at the details panel with this variable selected, you can see that again we see the variable name and we see the variable type. If I click on the variable type dropdown, we can see all the different types of variables that we have for use in Unreal. And there's a few more, or quite a lot more in reality under these dropdowns, but we'll just be sticking with some of the basic ones as an introduction here. So as I was saying, these data types or variables make our programming much more dynamic and flexible, allowing us to store different values and pull those values when we need them in this blueprint or other blueprints or anywhere else in Unreal, essentially. And this is really one of the tools that makes programming so powerful. So let's just go through some of these data types. We've already seen a Boolean in action in terms of this checkbox. So it's a true or false 0, 1 value. Next, we have a byte, which is like an 8-bit number, essentially. Then we have an integer, which is otherwise known as a whole number, so no decimal values. Next up, we have an integer 64, which is the same sort of concept, except it's a 64-bit integer. This just refers to how much data it can hold and how accurate it is. Next, we have a float variable or floating point number, which is like a decimal number, so this can hold, for example, 01.1 as a value, whereas an integer can't. Then we have a name, which is essentially like a string. A string and a name are very similar, except a name would be more specifically for a name of something. Then we have a string. A string is programmer speak again for just text. So this is how we hold text. There's also a more specific text variable, although string is a little bit more efficient than that in reality. Then we have a vector next. A vector holds 3 coordinates. So for example, x, y, and z. And we can use vectors to move things around, for example, in the scene. And later on, you'll see how we can make use of that to create a very basic sort of teleporter system. Next, we have a rotator, which allows us to control rotation. So where a vector would be controlling position, a rotator allows us to control rotation. And then we have transform, which is essentially a vector and a rotator, which allows us to transform an object, much like we saw with the transform handles earlier on in this video. To drag a variable into our event graph, we can once again just left click and drag it in. And when I let go, you can see that we can either get the value of an existing variable with the value assigned, and we can set that value dynamically on the fly or in our sort of graph sequence here. So one thing to note, if I just click off that, is you'll see down here we have a default value, and it says please compile this blueprint in order to see this value. So if I click on the compile button again, you can see that that default value is revealed, and by default it's false again, so is on is false, and we could set that to true if we wanted to by clicking on the checkbox, but I'll just leave it to off for now. And if I again left click and drag is on, but this time hold Alt, that's the shortcut for setting a variable, and if I hold Control and drag it onto the event graph, that's going to be this value, which is false again by default. So whatever value this is set to or holds, either by this set node or by this default value, will be determined or stored in this node, whereas this set node will allow us to set this to true or false whenever we want to. So to go over that again, just hold either Alt to set a variable or Control to get that value, or just simply click and drag it into the event graph and choose either get or set, respectively. So let's put these to at least theoretical use. So I'll delete this get node and just set this to true when the light is indeed on. So again, this is going to help us keep track of whether the light's on or off. It's not actually turning the light visibility on or off like the set visibility node is. So I'll just hook this execution pin up to the set variable, set is on variable, boolean variable to a certain value, and I'll make sure that because the light is on in this case, this value gets set to true too, which will allow us to fetch that value somewhere else and say, for example, if the light is on, spawn enemies. When the light is off, we can do the same thing or the opposite. So again, if I control D, I can duplicate any node that's selected and hook up this execution pin to this one and just untick the value saying that as this value states, the variable is indeed false. So just to give you an idea of something that we could potentially do with that, we have the viewport, which we've discussed, we have the event graph, and then in between that, we have what's known as the construction script. What this is really all about is whereas events unfold in the event graph dynamically over time, in the construction script, this is how the blueprint behaves sort of by default. It's kind of the default logic. So what I could do here, for example, is set our light intensity, but maybe only set the light intensity if the light is on. Of course, we won't really be able to see this in action, but theoretically, it's one thing that we could do. So what I could do is drag the point light in again to the construction script this time, and pull out this noodle or plug again, and search for set intensity in this case. And there we go. Whatever value we enter in here will be the intensity for this light. If we jump back to our scene, we can see what the intensity is. It's 139.76 or so. So I can make it higher than that, for example. So let's make it 200. And you can also see that this green color corresponds ultimately to the variable type for, let's just check, float. So we could also create a float variable to drive that number instead of having it kind of built into the node itself. So just as an example, let's create another variable by clicking on this plus sign. I'll call this light intensity. I'll switch the type using this dropdown to float. I'll drag it into the scene. I'll say get this value, and I'll hook light intensity up to that value. And then what we can do is we can compile our blueprint again so that we can see the default value for the selected variable over here or here, doesn't matter which one. And instead of 0 here, we can put 200. And that's doing exactly the same thing, but it's just to show you one use case for a floating point variable. Next, I'm going to introduce a new node type so we can access a whole host of nodes in blueprints by right-clicking anywhere in the gray sort of grid area. And in this case, I want to search for a branch node. So a branch node is the blueprint equivalent of an if or else statement or conditional statement. So in other words, we can say if a boolean is true, then do this, or if a boolean is false, then do that. So I'm going to select that. And then what we can see is here's our construction script constructor, essentially. If I plug this execution pin into this branch node execution pin, then the first thing that happens by default is we say, if something is true, then do this, or if something is false, then do that. What we can do is say, if the light is on, then change the intensity. So I'll say, if true, plug that into intensity, and then we need a condition. So the condition in this case will be the variable that we created called isOn. So what we can do is drag that in, just holding Control to get that value, which, if you remember, is whatever it's currently set to. So in the event graph, it could be set to true or false, depending on the logic that we have here. So if the player enters the box, the visibility turns on, and then this variable is set to true to keep track of that. So back in the construction script, it makes sense that if this is set to true by that logic, so in other words, the light is on, so we can hook that up to the condition, then it'll be true, and we can change the light intensity because the light is on. If we really wanted to, although we won't really be able to see this because the light will be off anyway, we could duplicate all of this, box selecting it by clicking and dragging, Control D, and we could hook up if false, And we could have a different sort of intensity for that. It could be 0. If we want to disconnect this new intensity, we can hold Alt and click to disconnect that. And for example, we could just say 0 for off. And to delete a node, you just select it and press delete or backspace. Lastly, it's a good idea to make sure that our variables down here are set to public. So what that means is that they're publicly accessible in different scripts or different blueprints or elsewhere in the engine, so in the level details panel itself. So the way that we do that is click on these little eye icons and open the eyes, making them public. This means that back here in the level, we'll be able to edit those a bit later on, and it prevents us from running into problems using them in different locations. So again, just make sure that you compile and save your blueprint, and then because this panel or this blueprint editor window is docked together with the level window in the editor, we should just be able to click on this play level in active level editor viewport button, or for short, the play button, and just preview and see what's going on. So if I move around here, you may have noticed that this isn't working as expected, and there are some ways to get it to work. So for example, if I just delete this set intensity and point light component coming out of the false exec pin, and I go to my isOn boolean and I set that to true instead of false, and I click play, we should expect the light to work. However, the reason that we're experiencing bugs here is that we're in the construction script, which doesn't take into account time as it evolves. So a better place for this would actually be in the event graph. So if I just select these nodes, we can also copy and paste nodes or cut and paste nodes with Control X and Control V for cut and paste, or Control C and Control V for copy and paste. So in this case, Control X to cut, going back to the event graph, Control V to paste. And what we could do instead is we can hook this up to this event tick node over here. So tick node or on tick is like an update function in Unreal. So it's on tick, or every frame or every second, then do something. So again, if I take my isOn node and I set that back to false and run this, we should expect to see that working, because now the tick function is taking time into account, whereas the construction script is only a good place to have your constructor logic or your default logic. Next up, let's explore some more debugging with the print string node. So if I right click in here and search for print, we can see the print string node. I'll just press enter to select that. I can also click on this drop down arrow to see all of the options available to us. So the way that the print string node works is we can get it to print string text to the screen. So again, like a string variable, but just string functionality built into this print string function. We know it's a function because we can see this little F that stands for function, by the way. And we can print it to the screen or to our log, our console log for debugging. We can change the text color that shows on the screen, and we can change the duration, how many seconds it stays on the screen for. And we can also enter an additional key or hook that up to an additional key. So if I connect this print string node to this part of the equation, and I change this from hello to isOn, and again, compile, save, or just run the game, and walk in here, we'll see isOn printing infinitely. And the reason for that is we're using that tick function again. So it's just going to show us that isOn every frame of the game infinitely for as long as the game is running. So if I disconnect this by, again, alt-clicking that exec pin, and I move this down to our original functionality from the onComponent begin overlap, set visibility to true, and then set isOn to true, and then just hook that up over there instead, and run that. We see isOn printing only once for 2 seconds while we're in that collision with the light switching on. If I go out and go back in, we'll see it again, because again, that print string is triggering every time this logic is completed. let's say we want to have a variable for health for our character. So we can create a new variable by clicking on the plus sign again. We can call it health. And usually I would use a float for health, but just to use something different, let's assume that this is going to be an integer or whole number variable. We're going to compile this so that we can change the default value to 100, so as if the player has 100% health. Let's say that every time the player walks into this, it's some sort of harmful object that damages the player's health. So we could use our tick function for this again, because it's going to check on every frame if it should remove health based on if we're inside this collider, again based on this Boolean logic that we set up earlier. So if I drag in the health variable and I say get health, and I then subtract from it, so we have all sorts of mathematical operations that we can use. So I can right click and just enter the minus sign, or just rather type in subtract is probably a bit easier. So I can hook up my health variable and I can have another variable saying -5, for example, or I could just enter here -5, or rather 5. And then I can use another print string to see the result of that. So I'll just duplicate this print string with Control D again. I'll hook up this exact pin, and all we need to do these days is just hook this up to in string, and we automatically get a integer to string node created for us, which converts a number value into text so that we can read it on screen. And now if I press play and I walk into that collider, we can see that health going down at least by 5%. And another thing we could do just to make this a little bit more interesting and realistic is we could get a health variable again, except this time holding Alt, we can set it to this new value each time we enter this box, and we can hook up our set intensity to that, and then the output exact pin over here to the print string node. And what we can do is just create some space over here by moving these nodes to the right, and just making some space so that you can see what's going on. And we can output this result of the subtraction into this health, which sets it as that new value. I'll just remove that toString node and recreate it by hooking up this output of the new value to the toString again, or inString again. And if we run that now, this will happen really fast, but if I move into the box, we can see the value going down in increments of 5 really quickly. So we could have some sort of logic saying once this gets to 0, then the player dies, and we can also set a cap on that. But hopefully that just gets the point across. Okay, and then for the last part of this tutorial, we'll just be looking at how to create a very simple basic teleporter system just using the vector variable type. So firstly, we will just look at where our character is in space, our first person character. So if I zoom in here, you can see we also have the event begin play, which is the start function in Unreal. So at the beginning of the game, do X, Y. So what I can do here is I can get my player character's location by first and foremost using the get player character node. So I'll right click and say get player character. So there's actually a built-in function for this in Unreal. Once I've got that, I want to get the axis location from this character. So we're going to pull out from this return value and search for get axis location. There it is. You can go up with the arrow keys. Once we've got this axis location, we want to store it in a vector variable and then show that vector variable on screen with the print string node so that we can see where this player is in 3D space. So once again, we'll create a new variable by clicking on the plus sign. We'll call this player location. We'll make sure that it's not an integer, but a vector variable type. We'll compile so that we can see that a vector is essentially a location in X, Y, and Z space. And then we'll set this variable to the current location. So we'll hold Alt and drag this out, and we get the set node, much like we've seen before, but with the X, Y, and Z values instead of true or false or number value. The set nodes, you may have noticed, also allow us to hook up the exec pin, so we can do that. And then we can output this return value from the actor location into that player location to store the player location in this variable. And that just allows us to print out this variable as text to the screen. So again, I'll just right click and search for another print string node. And we can just hook that up. If I want to, I can click on this color swatch and just change the color of that to something like red, just for a difference. We can also have it display on the screen for, let's say, 5 seconds. And instead of this hello message, we're just going to have this output of the player location plugged into that. And we have another toString node created for us, converting a vector into text or a string so that we can see it on screen. And lastly, if I run this, which should automatically compile and save that, you can see that at the beginning of the game, without going into the collision, because we're using that begin play node, we see those X, Y, and Z coordinates at the top left over here. So just like other variables, we can get an actor location, but we can also set a new actor location. So we can unhook this by alt-clicking it. We can even delete these two functions if we need to just clean things up a bit. And then when we enter the collision, we want the player to be teleported to a new location. So after this set true node, we'll get our player character again. And we'll, instead of getting the location, we'll set the location. So we'll set actor location. Which gives us this node. We can hook this exec pin up, and then we can use either this X, Y, and Z vector coordinates over here, or our existing variable that we made. So I'll control drag it in and hook that up, and make sure that this has some sort of X, Y, Z values that we want our player to teleport to. So if we need a frame of reference for that, we can just compile that, go back to our level. We could get a cube over here. We could move it off into a specific location, copy these coordinates, so it's 1800 about and 200. Come back here, match these up. So 1800 on X, 200 on Y, 0 on Z. And we can experiment and see if this works. And there we have it, we teleport to the other cube. So of course you could replace these cubes with more interesting objects such as very artistically, aesthetically pleasing teleport objects. It's a very simple trick, very basic, but you could expand on this. You could build on this logic. You could make your light do many other things like spawn enemies or cause damage to the player or give health to the player. So hopefully this tutorial has given you a lot of ideas in terms of what you can do in game logic and shown you how to execute this using data types or variables in Unreal Engine. And so I hope you enjoyed this tutorial. Good luck with your game dev journey and hope to see you soon. Cheers. Just in summary, today we explored the basics of Unreal Engine's blueprint system, starting with a basic example of switching a light on and off using Boolean logic, and then diving into variables and debugging using print string. We learned how to use vectors to manipulate actor positions and wrapped it up by creating a simple teleporter. These foundational skills will help you build and debug more complex mechanics in your Unreal projects. Keep experimenting and see what creative ideas you can bring to life. See you soon.